Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is Math 113, Calculus 2, Major Exam 2, Term 232. Let us have a look to the exam and solve it together. The first question is asking to evaluate the integral. Well, we have different methods to evaluate the integral, different techniques in Chapter 7. So here we have product of two functions. So whenever we have product of two functions, I'll try integration by parts. The formula says that integral uv integral u dv equals uv minus integral v du, Juventus minus integral v du. So we have to write this integral in this form. We choose one of the functions to call it u, and the other function will be called dv with the dx. The function we call it u follows this word, right? If we have a logarithmic function, then it is the first to choose to call u. So here we have ln x, so it would be our choice for u. So I'll say that u is ln x. The function that we call u, we need to find its derivative, du. The derivative of ln x is 1 over x dx. So this is u du. And if we call this u, then we still have fourth root of x with dx. These two we will call dv. So dv would be fourth root of x dx. And to find v, we need to find the integral of fourth root of x, which is x to the power 1 over 4. And the integral of x to the power 1 over 4 is x to the power 1 over 4 plus 1, which is 5 over 4 over 5 over 4, or multiplied by 4 over 5. Instead of saying over 5 over 4, we can multiply by 4 over 5. So now, if this integral is I call it I, then I would be equal to, according to the rule, uv. So u times v would be, I write 4 over 5 x to the power 5 over 4 first, and then ln x. So this is u times v minus integral v du. So v times du. So I have 4 over 5. I can take it outside the integral, and I have 1 over x times x to the power 5 over 4, and I have dx. So now to find the integral of x to the power 5 over 4 times 1 over x, I subtract the powers. I have x to the power 5 over 4 over x, so x to the power 5 over 4 minus 1, so it would be well, I'll call this integral double I, and I'll find it here. So double I is integral of x to the power 1 over 4 dx, because this is 5 over 4 minus 1. So it is as the same as dv. So in fact, the integral would be similarly v. So it would be x to the power 5 over 4. We add 1 and we divide by 5 over 4, or multiply by 4 over 5. So I'll have minus 4 over 5 times 4 over 5 x to the power 5 over 4 plus c, and I can write it finally. Multiply these two together. So I'll have 16 over 25. So this would be the answer of the first question. The second integral, I have sine cube times cosine square. This is a technique. We have how to deal with sine to the power n times cosine to the power m. Also tan to the power n times secant to the power m. You can check that in the videos. The formula or the technique says if we have sine and cosine to some powers multiplied, and if one of them has an odd power, so we have sine cube, we immediately take u equals cosine, the other one. And when we take u equals to cosine, then du would be derivative of cosine is negative sine theta d theta. So we need to, here in this integral, cosine, okay, I'll take it as u. So I'll have u square here. And I need sine theta times d theta to call it du, but I have sine cube. So I need one of them only. So I can write this integral as integral or negative. I need a negative inside, negative sine square theta. Okay, this is I don't need, times cosine square theta, which is okay with me, times, let me take negative sine theta here. Okay, so I erase it from here and write it there. So this would be du, and this would be u squared. So what about sine square? I don't need sine square, I need cosine. Can I change sine square to cosine square? Yes, sine square plus cosine square is 1. So sine square is in fact 1 minus cosine square theta. So I rewrote the integral in this form, and this form is ready to be changed from theta to u. So this one, 1 minus cosine square would be 1 minus u square, because u is cosine theta, and cosine square is u square, and this is product. And negative sine theta d theta is just du. So now I have an integral in u, which is easy to evaluate because I can just expand its product. So you have to expand. Integral does not distribute if there is a product. So 1 times u square, you have u square, and u square times u square is u to the power 4. And now the integral is ready. The integral distributed if there is a positive or negative sign. So I have negative, and integral of u square, we just add 1 to the power, and minus times minus would be plus u to the power 4 plus 1, which is 5 over 5. And that's the answer, but let us go back to theta, because we call the integral, the integral is in theta, not in u. So what is u? U is cosine theta. So I should write it negative cosine cube theta over 3 plus cosine to the power 5 theta over 5 plus c. And this is the answer of the question. Determine whether the integral is convergent or divergent. So it's an improper integral. You have 2 cases of improper integral. You can check the section about improper integrals, but one of them is when we have infinity or negative infinity, and the definition is we change infinity to b or to a letter, and we take b to infinity. So this would be the first step. We evaluate, we change it from improper to proper. We evaluate this proper integral and then we find the limit. All right, now how to find this integral? So let me work here. How to find this integral? Well, x squared minus 4, the derivative is 2x. I have x here, so I will divide by half, divide by 2 and multiply by 2 in the numerator. And now I can take u as x squared minus 4. Du would be 2x dx. So this is integration by substitution. And now 2x dx is du. And I have here square root of u. And I take it up, I write it u to the power negative half. And if it is u to the power negative half, the integral would be u to the power half. If you add 1 to negative half over negative half or times 2, 2 times half is 1. So in fact, the integral is u to the power half. And u is x squared minus 4. So it is the square root of x squared minus 4. So I have limit b goes to infinity, and the integral of this is square root of x squared minus 4 from 4 to b. And this would be the limit when b goes to infinity of, if I replace x by b, I'll have square root of b squared minus 4, and then minus replacing x by 4, 16 minus 4 is 12. So I have square root of 12. Now when I replace b with infinity, I'll have square root of infinity. Infinity square is infinity minus 4 infinity. Square root of infinity is infinity minus a number infinity. So the answer is infinity, and the integral is divergent. Write out the form of the partial fraction decomposition of this function. Do not determine the numerical values of the coefficients. Well, I will write it as 55x squared plus 90 over. Now the numerator doesn't have anything to do if we just want to write out the form. The form completely depends on the denominator. So what do we have in the denominator? I have x squared and I have x squared minus 9. So I write x squared first, and x squared minus 9 is x minus 3 times x plus 3. And I have x squared plus 9. Well, we cannot factor x squared plus 9. It is an irreducible factor. X squared is a linear factor raised to the power 2. So we write a over x plus b over x squared. When we have power 2, we do like this. And we have x minus 3. This is a linear factor. And x plus 3, this is a linear factor. And for the irreducible quadratic, we use ex plus f, a, b, c, d, f, for example. This should be linear now, not just a constant. And this is, in fact, the partial fraction decomposition. Now, the numerator is important if we need to find the numerical values, the values of all of these constants. But he said do not determine, so that's the answer. Set up only, do not evaluate an integral for the length of the curve. The length of the curve, arc length. We have two formulas for the arc length, which we call L, capital L. Now, y works from 0 to 1. So I'll use this one, this formula, in which L is written in terms, L in general is integral ds, okay? Integral ds. And ds, we can write it in terms of dx or dy. Here, y is running from 0 to 1, so I will write it as dy. So y will work here from C to D. You have to find y from where to where, which is 0 to 1. And inside, I have the square root of 1 plus dx over dy to the power 2. If you have x in the question, x from 0 to 1, for example, then this would be dx, and this would be dy over dx to the power 2. So the arc length would be from 0 to 1, integral 1 plus dx by dy. It is solved for x, so all what you need to find is the derivative of x with respect to y, so x prime in this case. So the derivative of x with respect to y is, what is the derivative of ey? It is ey plus 1 over 4, that's constant. Derivative of e to the power negative y is e to the power negative y times negative 1. So times negative 1, the derivative of negative y, so I'll change the plus to minus, and I raise it to the power 2 dy. So this would be the answer. If you want to take it one step further without evaluating the integral, then let me expand the power. So I'll have e to the power 2y minus 2 times 1 over 4 is 1 over 2. E to the power y times e to the power negative y is e to the power y minus y, which is 0. And e to the power 0 is 1. So the answer would be negative half. This is 2 times the first times the second terms. Then plus the square of the second term, which is 1 over 16 e to the power negative 2y. And I can finally write it as square root of e to the power 2y. 1 minus half would be positive half plus 1 over 16 e to the power negative 2y. If he asks to continue, so this would be the answer. But we can write the three terms in the middle now. We can write them as e to the power y plus 1 over 4 e to the power negative y squared. Because when we expanded this one, we got these three terms. And now the only difference between these three terms and these three terms, this is negative half and this is positive half. So this would be like this. Under the square root, then the square root cancels with 2, and we will have this inside the integral, and this is easy to evaluate to find the integral. But he didn't ask to continue, so this would be my final step. Find the exact area of the surface obtained by rotating the curve about the x-axis. When we rotate the curve about the x-axis, the formula says that the surface area is equal to 2 pi y times ds. Y is the radius in this case. If it is about the y-axis, the formula would be 2 pi x instead of y. So if it is the x-axis, it is y. If it is the y-axis, it's x. And now ds, as we mentioned in the previous question, we can write it in terms of dx or dy. And this depends on this. He gave me x between negative 2 and 2. So I'd like to write this as from negative 2 to 2 pi y. And ds is, as we mentioned, it is the square root of 1 plus dy by dx in this case to the power 2, because we need to integrate with respect to x. Now, y, this is y. So y prime or dy by dx would be derivative of square root 1 over 2 times the square root times the derivative of 9 minus x squared. Derivative of 9 is 0. Derivative of negative x squared is negative 2x. And I cancel 2 with 2, and I raise it to the power 2. So I'll have integral from negative 2 to 2. 2 pi, I can take it outside, or you can keep it inside. It really doesn't matter, but I'll take it outside. And now y. Well, keeping y as y is not doesn't work because I have dx. I need to integrate with respect to x. So I should change y by its definition. Y is square root of 9 minus x squared. So this would be nice. And now I have integral of 1 plus derivative of y squared. I'll cancel 2 with 2. And when I square negative x, it would be x squared. Okay, I have, this is 1 over plus, okay, dy by dx is, yeah, good. So x squared over, there is no 2 now, square it, I have 9x squared. Squaring the root will cancel the root will disappear. So this is y prime squared times dx. And now here you can do whatever you like. You can add these two terms and then multiply, or you can just, it would be easier here. If we multiply the two roots, you know, we can multiply square root of x times square root of y. We can write it square root of xy. This is one of the properties of square roots or roots in general. So I'll have square root 1 square root of 9 minus x squared times 1. This would be 9 minus x squared plus, now when I multiply 9 minus x squared times x squared over 9 minus x squared, then these two will be cancelled. And I'll have 9 minus x squared plus x squared. And then negative x squared will be cancelled with positive x squared. And I'll have integral of square root. Let me write it like this first, and then cancel. And the square root of 9 is 3. So it's, in fact, I can take the 3 outside. So it's 6 by from negative 2 to dx. And this integral is very easy. You can evaluate, you can say it's x from negative 2 to 2, or in fact, we have a formula or a property that says integral from a to b dx is b minus a. So it's 2 minus 2. That's 4 times 6 pi, that's 24 pi. So that's the answer. Evaluate the following integrals. Well, I can't use substitution here because x squared minus 1, the derivative is 2x. I have x to the power 4 below, so usual substitution doesn't work. But trigonometric substitution here works because I have this root, square root of x squared minus 1. We have 3 roots we can use trigonometric substitution with. This is one of them, and I can take x, I can call x secant theta. If it is in this form, x squared minus 1, we call x secant theta. And then dx would be derivative of secant is secant theta tan theta d theta. So I'm going to change the integral from x to theta. And for that, I need to change x to the power 4. Okay, will be secant to the power 4. But what about this square roots? I'll call this integral. So square root of x squared minus 1 would be the square root of secant square theta minus 1. And we know that tan square plus 1 is secant square. So secant square minus 1 is tan square. And the square root of tan square is tan theta under the conditions with this substitution. We choose values of theta in which the square root would be positive tan theta. So I can change now I from x to theta. The square root is just tan theta. And x to the power 4 is secant to the power 4. And dx is secant theta tan theta d theta. So secant cancels with secant to the power 4 below. I'll have secant to the power 3, and tan times tan would be tan square theta d theta. And now what to do with this integral? I have tan square over secant cube. So I will just change it to sine, change everything to sine. Remember, we have technique to deal with tan times secant. And if tan has power, odd power, or secant has even power, and we don't have the situation here. So I'll just change tan square to sine square over cosine square. And secant cube is 1 over cosine cube. So in fact, 1 over secant cube would be cosine cube. You can just write it like this. And now I have cube and square, so they cancel. And I'll have sine square theta times cosine theta d theta. And since I have cosine to the power 1, so immediately I take u as sine theta. So du would be cosine theta d theta. And this integral would be integral of u squared, because sine is u squared, and cosine theta d theta is du. And the answer would be u3 over 3 plus c. And now we should go back to theta. So this would be, instead of u, I have sine cube theta over 3 plus c. And now I should go back from theta to x. And the relation between x and theta is this one. X is secant theta. So if x is secant theta, then cosine theta would be 1 over x, because, you know, secant is the reciprocal of cosine. So if this is theta and cosine is 1 over x, cosine is adjacent over hypotenuse. You know, so katwa. So adjacent over hypotenuse. So adjacent of theta is this one, should be 1. This is hypotenuse. And this is the opposite. It should be hypotenuse square x square minus 1. So, and as usual, this should be the integral in the root in the question to make sure that your answer is correct. So the final step would be, instead of sine theta, what is sine theta? It is opposite over hypotenuse. So 1 over 3, I'll write it here, and I'll have square root of x squared minus 1. This is the opposite over hypotenuse, and this should be raised to the power 3 plus c, and this would be the answer. The last question, I have a polynomial here and x minus 5. Well, if I take the derivative of x squared plus 3x minus 4, it would be 2x plus 3. And I have here x minus 5. If I multiply by 2, it would be 2x minus 10. So I can take 2x plus 3 and then minus 7 over, and minus 7 over this, I have to use fraction decomposition. So I'll use it from the start. I write the decomposition of x minus 5 over x squared plus 3x minus 4. And to do that, I need to factor the denominator. And the denominator is x plus 4 times x minus 1. 4 minus 1 is 3. Negative 1 times 4 is negative 4. And we have two linear factors, so we write them as a over x plus 4 and b over x minus 1. And the easiest way to find a and b here is to replace x by negative 4 in this side. Okay, so minus 4 minus 9, a would be minus 4 minus 5, that's negative 9. And we cannot replace x by negative 4 here because it would be 0. So we just replace it here. Negative 4 minus 1 is negative 5. So in fact, a is 9 over 5. And if x is 1, I take x1 here to find b. So b would be replace 1 minus 5 is negative 4. And I don't replace x by 1 here because it will make it 0. I replace it here. 1 plus 4 is 5. So if this integral is I would be now integral of a over x plus 4. So it's 9 over 5 over x plus 4 plus, or you can write it minus, because 4 over 5, because b, of course, if you want to write dx here, integral 4 over 5 over x minus 1 dx. And finally, the integral, the answer would be 9 over 5 is just constant, and integral of 1 over x plus 4 is ln absolute value of x plus 4. 4 over 5 is constant, and integral of 1 over x minus 1 is ln absolute value of x minus 1, and we put C. This was the last question. It is an easy major. Wish you good luck.